Hello friends, I welcome you all to our channel Board and Beyond. So today we are going to have lecture number 2 on linear equations in two variables. Right friends? So in last class what we have seen is that what is a linear equation in two variables and the basic understanding that we have got from the previous class, right? So in this class what we are going to learn is how do we find out a solution graphically for a system of linear equations in two variables, right friends? So with that background, let us move forward and try to solve problem and then basically get some understanding, right? So friends, this question has already appeared in the examination but a few years back, okay? And the question says that solve the following system of linear equation graphically. That means we need to plot a graph and then plot these two lines as well, okay, and then hence by find the solution for x and y, okay, and find the area of the region bounded by these lines and x axis, okay, right friends? So let us move forward. So friends, as I told you in the last class, what we do is that whenever you have to plot a graph, okay, or find a solution for a system of linear equation graphically, then what do you do is that you express one variable in the form of another variable, okay? So it will be clear here, right friends? So let's try to solve this. So solution. The first equation given to us is, my friends, 4x minus 3y is equal to 4. Sorry. Minus 4 we can say, right, when I take this term that side, okay? So this becomes minus 3y is equal to minus 4 minus 4x, alright, okay? So taking minus 4 and minus, I multiplying across with minus sign, friends, so this becomes 3y is equal to 4x plus 4, right? And y is equal to 4x plus 4 divided by 3. So I have expressed y in terms of x. Now what do we do, friends? We draw a table here, or we make a table here and then take some random points, okay, and then right, let us say this is x and this is y, y. So what do we do, friends? We assume certain values of x. Let us say we assume x is equal to 2, right? So what happens? Let us say x is equal to 2. So this becomes 8 plus 4, that is 12. 12 divided by 3 is nothing but 4, right friends? Let us say x is equal to 0. What does it become? 4 by 3. Okay, let it go in fraction, no problem, we will plot fractions only, absolutely no problem. Let us take some negative value of x. Negative value of x, let us say I take minus 2, minus 3 if I take, yes, let's take x is equal to minus 3. What happens? This becomes minus 12 plus 4, that is minus 8, right? Minus 12 plus 4 is minus 8 divided by 3, minus 8 by 3. No problem, we will plot this thing. So let's take x is equal to 1. What happens? If I take x is equal to 1, this becomes 8 by 3. Right? I think enough for us to plot. Okay. Now coming on to the second one, my friends. So 4x plus 3y is equal to 20, we can say. So 3y is equal to 20 minus 4x, we can say, or y is equal to 20 minus 4x divided by 3. Okay, let's again make a table for this. X and y. Let us say x is equal to 2. what happens? 20 minus 8, that is 12. 12 by 3 is nothing but 4. Let us say x is equal to 1. What happens? This becomes 20 minus 4, that is 16 by 3. It doesn't divide, no problem. 16 by 3. Okay. Let us say x is equal to 0. Okay. So this becomes how much, my friends? This becomes 20 by 3. Let it be 20 by 3. No problem. Now let us say 2, 1, 0. I'll take one negative value. Let us say x is equal to minus 1. What happens? This becomes 20 minus 4, 6. If this becomes minus 1, this becomes 20 plus 4. That is 24. Divided by 3 is nothing but 8. Right, friends? So with these two information, we will plot the graph here. Okay. So this is our y-axis, x-axis, minus x, minus y. Okay. Now this is 0. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Right? I'll write it also. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. Okay, and this is minus 8. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. Right, friends? So let's start plotting this graph, friends. Right? So we'll come here. X is equal to 2, y is equal to 4. X is equal to 2, y is equal to 4. So somewhere this is the intersection of the point. X is equal to 2, y is equal to 4. Right? Okay, friends. Since we have already started plotting, so I just wanted to tell you one thing before we actually start plotting. Okay, so see, just observe these two tables minutely. Okay, so what do you observe? Do you see that whatever I am encircling it now, okay, are same for both the equations? X is equal to 2 and y is equal to 4. So friends, this signifies that when you are plotting the graph, you will get an answer for x and y, right? So the x and y which you get from the graph should be x is equal to 2 and y is equal to 4 is the solution for these two simultaneous linear equations, right? So this is only a cross check point. You need not mention it anywhere in the answer sheet, right? So what happens is when you have plotted the graph and if you are not getting these values, then better you recheck the graph immediately thereon. Because after doing everything, if you want to recheck that, then it actually consumes time, which you can utilize for doing some other problems, right, friends? So with this, let me further continue, right? So x is equal to 0, y is equal to 4 by 3. So x is equal to 0, y is equal to 4 by 3. 4 by 3 is nothing but 1.3. So I will take it somewhere here. X is equal to 0 and y is equal to 4 by 3. This is quite small here because I cannot write big, so I am just reading out this thing also. X is equal to minus 3, y is equal to minus 8 by 3. X is equal to minus 3, okay, y is equal to minus 8 by 3. Minus 8 by 3 is how much, my friends? 2 and 2.6 almost. So 2.6, let us say 2.5, more than 2.5. I just draw it here, and x is equal to minus 3. I just take this point, right? So minus 3 and minus 8 by 3. You can do it very, very correctly on the graph sheet. Okay. So this is only now x is equal to 1 and y is equal to 8 by 3. Let us say x is equal to 1 here and y is equal to again 8 by 3 is nothing but 2.6. Okay. So 2.6 is almost more than 2.5. So this and this. So this is the point. X is equal to 1 and y is equal to 8 by 3. Right? So now what do we do, friends? We join all these points. Okay? This way. Okay? So this I'll extend it further on other side also. So this line is a representation of which of the equation, my friend? 4x minus 3y is equal to minus 4. I'll write it here. 4x minus 3y is equal to minus 4. This is representation of this equation, or you can say this also as well. Plus 4 is equal to 0. Both the same things, right? Both are the same. Now let's start plotting this one. So 2 and 4, x is equal to 2 and y is equal to 4. Again we come back to the same point. I'll write it once again. 2 and 4. Okay. X is equal to 1, y is equal to 16 by 3. X is equal to 1 and y is equal to 16 by 3. 16 by 3 is how much, my friends? 3 5 is 15 plus 1. So 5.1 almost. So 5.1, almost 5. X is equal to 1. X is equal to 1, y is equal to so this 5.1. Let me just do here and this. So this point, x is equal to 1, y is equal to 16 by 3, right? X is equal to 0, y is equal to 20 by 3. X is equal to 0, y is equal to 20 by 3 is nothing but 3 6 is 18, again 6.6, 6.6 almost here. X is equal to 0, y is equal to 20 by 3. 0, 20 by 3. Right, friends? X is equal to minus 1, y is equal to 8. X is equal to minus 1, y is equal to 8. 8 is again further up. So this point, x is equal to minus 1 and y is equal to 8. Now I try to basically join these points. Right? So 1 second, friends. 1 second. 1 second. There is a small in this sense. This will come like this, friends. This will come like this, okay, when you plot it on the graph. Now, friends, let's do one thing. This is about plotting the graph. Okay, I need to write 4x plus 3y is equal to 20. So this line, it is representation of 4x plus 3y is equal to 20. Right. Okay. So now the plotting has been done. Now we come on to the second part of the problem. The second part of the problem says that we need to find out the area enclosed by these lines and x-axis. Right. So where is my x-axis? This is my x-axis. Right. And these lines are crossing like this. So area enclosed between these lines and x-axis is nothing but this. Right? So let us say I name it as A, B and C. Okay? So in other words, can I say, my friend, that area enclosed by these lines and x-axis is nothing but the area of the triangle A, B and C. Right? Okay? If it is not visible, let me just write it little bigger. A, B and this point is C. Okay? So area of triangle A, B and C. Correct? So now area of triangle ABC, shall I do it here? Yeah, no problem. So area of triangle A, B and C is nothing but half into base. What is the base, my friend? See, this is 5 here and this is -1. So the total distance here is 6 into height. What is the height, my friends? Height is this, right? So height is nothing but the cross point of intersection and other distance, y-axis distance, that is equal to 4. Right, friends? So this is equal to 3 into 4, that is equal to 12 square unit. Okay. So this was what expected out of you in the examination. It was for 5 marks. Sorry, 4 marks. I'm so sorry. It was for 4 marks. Right, friends? So if any one of you want to take a screenshot, you can do it now, or I'll be basically moving on to the next one. Okay, I move aside from the board. Okay, so I'll just wrap it off. So now we move on to a new concept, my friend, that is simultaneous linear equations. Okay, and how do we solve a simultaneous linear equation? So first of all, let us get some understanding about what is a simultaneous linear equations, right? So simultaneous linear equations are nothing but when you have got a pair of equations in 2 variables, right? And you find out the values of x and y, right? If the value of x and y which you have found out, you can use any method for that. So if for the values for x and y which you have found out, if that x and y value satisfies both the equations simultaneously or both the equations, then we say that this is a simultaneous linear equation, right? Okay, so with this understanding, let us try to understand with one example. Okay, so we can say, we can take this only. Okay, simultaneous linear equations. So with this understanding, let us try to understand how do we solve simultaneous linear equations. So friends, there are 3 methods basically. Okay, one is a graphical method, one is a substitution method, and one is a cross multiplication method. Okay, so we have seen graphical method. Okay, so now we will see substitution method of solving simultaneous linear equations in 2 variables. Right? With the example, I'll illustrate how do we do that. Okay, so let's take an example. Question is 2x plus 5 is equal to 7. Okay, and there is another equation 4x minus 3y is equal to minus 1. So these are the 2 simultaneous linear equations which has been given to us, and we are expected to find the values of x and y, okay, through substitution method. Okay, so substitution method is nothing but use the equation number 1, that is equal to this, and this is 2. So using one equation, we express one variable in the form of another variable. Okay, and then using whatever we have expressed in another variable, other variable, so putting that back in the second equation, we actually find out the values of one of the variable, right? Then substituting that in the previous equation and then finding out the other value. Slightly confusing? Let me do it here. Okay, so let's take any one, right friends? So let's take up this one. 4x minus 3y is equal to minus 1, right? So 4x minus 3y is equal to minus 1 has been given to us. So can we write 4x is equal to 3y minus 1? This will become plus. So x is equal to 3y minus 1 divided by 4, right? So this is from 2. Now substitute this value of x in 1. Okay, so substituting it in 1. Substituting x in equation 1. So what happens, my friend? My first equation says 2x plus y is equal to 7, right? X is equal to 3y minus 1 divided by 4 plus y is equal to 7, right? I have substituted this. So this becomes, I can cancel it out. So this becomes 3y minus 1 plus 2y divided by 2 is equal to 7. What I have done? I have taken the LCM out here, friends. Okay. So this is equal to 3y plus 2y is nothing but 5y minus 1 is equal to 14. You are all there with me? Right? So this is 5y is equal to 15 and y is equal to 5. Okay. So we have found the value of y. Correct? Now what we are going to do is that we are going to replace this or put this value of y in equation number 2, right? Because from there we have find out, we have plotted here, now we will put it here, right? So that is equal to 4x minus 3 into y is nothing but 5 is equal to minus 1. You are able to get it? Okay. So 4x minus 15 is equal to minus 1, right? So 4x is equal to, this becomes plus and this becomes 14. One second. Yeah, sorry, you put it in the other one. No problem. It's all the same, by the way, but let me put it here. 2x plus y is equal to 7. Y is 5. So 2x plus 5 is equal to 7. So 2x is equal to 2. X is equal to 1. Right? So y is equal to 5. Okay. So let's try and check it. 2x, that is 2, plus y is equal to 5, that is equal to 7. You are getting it? We can cross check also, my friends. That is putting the value of x and y, okay, in any one of the equation. So let's put it in the first equation. So 2x is nothing but 2 into 1, that is equal to 2, plus y is equal to 5, so is equal to 7. It satisfies my equation. So whatever solution we have found out, that is x is equal to 1 and y is equal to 5, is a correct solution. Right, friends? Okay. So we can take any other example also, just for this thing. Let us say, I'll take one example. Okay, let's say 2x plus 5y is equal to 14, right? And let us say 3x plus 8y is equal to 20. So these are the two simultaneous linear equations which has been given to us, and we are expected to find the value of x and y through substitution method, right? So let's try to find out. This becomes 2x is equal to 14 minus 5y, right, friends? So x is equal to 14 minus 5y divided by 2. Correct? Now putting this value of x in the second equation, so this becomes 3 into 14 minus 5y divided by 2, right, plus 8y is equal to 20. So this becomes how much? 42 minus 15y plus 16y is equal to 40. Did you all understand? what I have done is that I have opened it up first, then took the LCM, that is LCM is equal to 2, and then I multiplied it with 2, and then I have taken the 2 that side. Okay, so I have skipped a few steps here. So this becomes 42 plus y is equal to 40. So y is equal to minus 2. Right, friends? Now, if y is equal to 2 minus 2, then let's put it in this first equation, right? So this is 2x plus 5 into minus 2, that is equal to 14. You all are getting it? So 2x minus 10 is equal to 14. So x is equal to how much, my friends? Let's say 2x first, that is equal to 24. So x is equal to 12. You are getting it? Now, these values of x and y, when you put it in any one of the equation, it should satisfy. Let's put it here. So 2 into x, that is equal to 24, plus 5 into y is equal to minus 2, that is minus 10. It should be equal to 14, right? So is it 24 minus 10 is equal to 14? Yes, true. Okay, so this is how you basically solve two simultaneous linear equations in two variables through substitution method. Okay, so with this we will wind up the session here for this, and then in next class we will see elimination method, and we will also see cross multiplication method, friends, right? Okay, so till the time we meet next, thank you so much for listening to us, and then basically till the time we meet next, be happy, keep learning with us. Thank you so much.